Today's lesson is about three special quadrilaterals. That's what they're called: rhombuses, rectangles, squares. And a rhombus is any quadrilateral with four congruent sides: 1, 2, 3, 4, all the same length. A rectangle is any quadrilateral that has four right angles. So notice it's a quadrilateral, all the angles are congruent, and so these two sides are going to end up being congruent, and these two sides are going to end up being congruent. But they can be any size. They're not all four, don't have to be congruent. And a square is the combination of both, right? So quadrilateral with four congruent sides and four right angles. So think about the relationships of them, right? Every square is a rhombus and is also a rectangle, but not every rectangle is a square, and not every rhombus is a square. And then where do they fit in terms of all quadrilaterals and all parallelograms, right? So not every quadrilateral is a parallelogram, right? We could draw that like that. That's not a parallelogram, but it is a quadrilateral, has four sides. Okay, and then within parallelograms, we have the three: the rhombuses or rhombi, squares, and rectangles. And again, so they're all parallelograms. So their opposite pairs of sides are all parallel. Their opposite side pairs are congruent, and their opposite angles are congruent, right? All of the things you learned the other day about parallelograms apply to squares, rectangles, and rhombuses, okay? Later, we'll discuss trapezoids and kites, and you can see where they fit in, right? They're quadrilaterals, but they're not parallelograms. So this is something where if you need this to kind of help shape where things belong, right? You can take a screenshot of that and use it later. Okay, so here's a little animation they made about the opposite angles of a rhombus, right? So if you watch this as you move it around, notice the opposite pairs of angles are always congruent. It doesn't matter what's happening to the sides, right? All the side lengths are the same, but no matter what's happening to those, these are congruent and these are congruent. So let's look at the question. For any rhombus QRST, decide whether the statement is always or sometimes true. So Q and S, right? Q is over here. And notice if it says QRST, the vertices have to be in that order. So it has to be Q, then R, then S, then T. And that's how you know when you draw it that you're following the right guidelines. So anyway, Q is congruent to S. So Q is here, S is here. They are opposite sides. So yes, they always have to be congruent. That's what we just saw in the animation, that opposite angles are always going to be congruent. Okay, Q and R. Now Q is here, and R is here, and you can see right here in this example they're not congruent. So we know right away they're not always going to be congruent, but sometimes they can be. And that one example is going to be if your rhombus is a square. If your rhombus is a square, then all of your angles are 90 degrees, and so obviously Q and R, no matter where they are, would always be 90. So that is sometimes true, and that is sometimes true when your rhombus is a square. Okay, so next we're going to look at the diagonals. So we're going to first look at the diagonals of a rhombus, then we'll look at the diagonals of a rectangle, and then we'll keep in mind that whatever applies for a rhombus or a rectangle all applies for a square, because a square is a type of both, right? So let's look at the diagonals of a rhombus, and what we want to notice is that they're perpendicular, right? This 90-degree angle is never going to change, and they're also angle bisectors. So look at the interior angles. No matter what happens to that rhombus, those bisectors are always intersecting at a 90-degree angle, and they're always cutting the opposite angles in half, right? 61 and 61, 29 and 29, 61 and 61, 29 and 29, and that's always going to be true. The rectangle, okay? The diagonals in a rectangle are always congruent, right? The length. So the 4.87 is the one of the diagonals, and the 4.87 is the other diagonal. And just look, no matter what's happening, this is going to be congruent. So the whole time, they are always the same length. The diagonals are always the same length. Look at a couple more questions where we're classifying shapes and then applying the properties that we know about them to figure out what they're asking us. So classify the quadrilateral, then find X and Y. All right, so what do we know? Well, right away I see that all the interior angles are 90 degrees. So that means this shape has the qualities of a rectangle. But I also notice that this is 90 degrees, right? So the intersection of the diagonals is a right angle. And I know that that means that it has the qualities of a rhombus. And so the shape that has the qualities of a rhombus and a rectangle is a square. So I know that this shape is in fact a square. So even though I don't know, or I didn't know a second ago, that all the sides are the same length, I do know that now. I know that's a square. I know that all the side lengths are the same, right? And that's because it has the qualities of a rhombus and a rectangle, and that means that it's a square. Okay, so now find x and y. So y, we'll start there, right? So I know that y, 2y, right? I know that this diagonal is getting bisected, right? So I know that 2y is the same length as 10. So I can just say, okay, well, I know that 2y is the same as 10, divide by 2, and I know that y is 5, okay? So it's pretty easy. Now for x, remember the diagonals of a rhombus bisect each other, right? So I know that 5x is the same as whatever this little angle is over here, but I know that this whole angle, I'll switch colors for a second just to point this out. I know this whole angle is the same as this whole angle. And I know if the whole angles are the same, then half of those angles is also the same, right? So I know that actually all 4 of these angles, those 2 and the ones up near Q, I know all of them are the same. So even though they're on opposite sides, I know that 5x is the same as 3x plus 18. And so 2x is 18 and x is 9. Next. So this is pretty open-ended, but it's going to be a good sort of lead into a proof. So ABCD is a rectangle. Write down everything that you know about it. All right, it's a rectangle, right? So a rectangle is a parallelogram. You can go back to the diagram where, and that is really ugly handwriting, I apologize, but we know it's a parallelogram. And if it's a rectangle, we also know that it has 4 right angles. Right, that was the definition we had for a rectangle, a quadrilateral with 4 right angles. Okay, so that's 2 things we know. But remember, if it's a parallelogram, there's some other stuff that we know about it too, right? We know that opposite angles are congruent. So that means A and C and B and D. And in this case, because it's a rectangle, they're all 90, they're all congruent, okay? But we also know that opposite sides are both parallel and congruent, right? So AD is not only the same length as BC, but these 2 lines are parallel, and AB is not only the same length as DC, but these 2 sides are also parallel. The last thing is we know that in a rectangle, if we draw the diagonals, they're going to bisect each other. So if we wanted to call this E, right, we know that AE, and I already did 1 and 2, so we'll do 3. AE is the same length as EC, and they bisect each other, so both are getting cut in half, so that DE, 1, 2, 3, 4, is the same as EB.